right, this lesson is over partial fractions, section 9.4. Right, partial fraction decomposition is a method used to write a given rational expression as a sum or difference of simpler rational expressions, which is often helpful when integrating in calculus. When performing partial fraction decomposition, the degree of the numerator must be less than the degree of the denominator. So when you add two fractions, you must have a common denominator. So for example, if we were adding these two rational expressions together, let me just change my ink color. I don't really care for that color. I would have to get a least common denominator. And so what I would do is my least common denominator would be x minus 1 times 2x plus 1. So I would have to multiply this 1 by 2x plus 1. And I would have to multiply this 1 by x minus 1. Because I'd be multiplying this by x minus 1. And I'd be multiplying this side by 2x plus 1. And so on your numerator here, you would have 2x plus 1. 1 times 2x plus 1 plus 1 times x minus 1. And this would equal 2x plus 1 plus x minus 1. And so notice here, these cancel, and you end up with 2x plus x, which is 3x, over x minus 1 times 2x plus 1. Okay, so we just added those two simpler rational expressions together by getting a common denominator first. So on this next slide, you can see that 1 over x minus 1 plus 1 over 2x plus 1 is equal to 3x over 2x squared minus x minus 1. So in this section of partial fractions, we're starting out here, and we're going to work backwards to get these partial fractions here. Okay? So there's 4 different cases that we're going to need to consider. The problems that are numbered in this section are the ones that you'll actually find in your homework in Lumen. So I'm probably going to, so that this isn't a super long video, I'll go ahead and jump to the problems, and we'll start working through these. But on all of these, what you're going to want to do is factor the denominator first. And in some of the examples, the denominators have already been factored for us. Okay, but there are 4 different cases that can arise, although in the homework, you're probably only going to see a couple of these. So this is the first kind of problem that you're going to see in your homework. Okay, so the partial fraction decomposition of 16 over x minus 1 times x plus 1 can be written in the form of f of x over x minus 1 plus g of x over x plus 1. So notice that the denominator, they've already factored it here for you. Okay, now x minus 1 and x plus 1 are linear factors. So f of x and g of x, those are just going to be constants. So when you rewrite those, 16 over x minus 1 times x plus 1 is going to equal, I'm going to call f of x a over x minus 1 plus b, that's your g of x, over x plus 1. Okay? And so what you'll do now is you're just going to multiply everything by the least common denominator, which is x minus 1 times x plus 1. And why don't I just go ahead and get a different ink color here. I'll go back to red. So we're going to multiply everything by x minus 1 times x plus 1. So when you do that, notice this cancels with this. X minus 1 cancels with x minus 1. This is an x plus 1. This x plus 1 cancels with this. So you're left with 16 equals a times x plus 1 plus b times x minus 1. Now in this first example, normally we'll go ahead and distribute, and we'll come up with a system of linear equations that will solve by elimination or substitution. But in this first example, it's easier actually to solve it by just saying let's just say that let's say x is equal to 1. If x were equal to 1 and we plug that in, well, that would mean that 16 would equal, well, 1 plus 1 is 2. So that would be a times 2 plus, well, 1 minus 1 is 0, and 0 times b is 0. So we just would get 16 equals a times 2, right? So we would just get 16 equals 2a, divide both sides by 2, so a would equal 8. All right, and then to solve for b, we'll just say, well, let's let x equal negative 1. If x equals negative 1, we would get 16 equals, well, a negative 1 plus 1 is 0, so 0 times a is 0, but negative 1 minus 1 is negative 2. That would be b times negative 2. So 16 would equal negative 2b. Dividing both sides by negative 2, b would equal negative 8. Okay, so this is the only one that we're going to solve this way. And in the next examples, I'll show you how to solve them the other way. So setting this up, we will have, so a, which was our f of x, our partial fraction decomposition is just going to equal 8 over x minus 1 plus b, which is negative 8 over x plus 1. So you can see your f of x is equal to 8 and your g of x is equal to negative 8. All right, let's go ahead and look at the next example. And I do have some blank slides in here because I didn't know how much room I would need. Okay, so in this example, number 2, and this is another one that you'll find in your homework, one like this. Notice the denominator has not been factored yet, so we're going to need to factor that. Okay, so if we factor that, we'll have 43x plus 42. We'll just leave our numerator the same. So factors of 12, I'll try 4 and 3, so that would be 4x times 3x. And factors of 7, 1 and 7, and just make sure your inner and outer add up to 31. So that would be, that would be 3x, 28x, that adds up to 31x. Okay, so notice we still have 4x plus 1 is a linear factor, and 3x plus 7 is a linear factor. Okay, so that means when we set up our partial fractions, we can set that up as a constant a over 4x plus 1 plus a constant b over 3x plus 7. So now let me just grab a different color. So now I'm just going to go ahead, I'm going to multiply everything by the least common denominator, which is 4x plus 1 times 3x plus 7 4x plus 1 times 3x plus 7. 4x plus 1 times 3x plus 7. Okay, so this goes away. I'm left with 43x plus 42 is equal to a times 3x plus 7 plus b times 4x plus 1. Now it's not so convenient now to plug in values for x on this one, so I'm going to go ahead and distribute on this one. I'm going to get 43x plus 42 equals 3ax plus 7a plus 4bx plus b. And now let's just group, so I have 43x plus 42. Let's go ahead and group your x terms. So we have 3ax plus 4bx, and group your constant terms, your 7a and your b, plus 7a plus b. And now notice, if you look at your 3ax and your 4bx, I'm going to factor out that x. So 43x plus 42 is going to equal 3a plus 4b. I'm going to factor out the x and put it on the outside. And then your constant is 7a plus b. Okay? So now notice your 43 here must equal your 3a plus 4b because that's your x term. And your 42, which is your constant, must equal your 7a plus b because that's your constant term. So we have two equations that we can set up now. And I'm just going to change back to a different color here. Let's go to black. So that means that 3a plus 4b equals 43. And 7a plus b equals 42. And now I can just, I'm going to use I'll use elimination to solve this. So I'm going to multiply this bottom equation by -4. So on the top, I'll just leave that the same. 3a plus 4b equals 43. On the bottom, I'll have -28a minus 4b equals 42 times 4 is -168. So that gives me -25a equals -125. Divide both sides by -25. And a equals 5. Okay, so now I can just plug that back in to figure out what b is equal to. So we know that 3a plus 4b equals 43. I'll just do that right up here. We know that 3a plus 4b equals 43. So 3 times 5 plus 4b equals 43. So 15 plus 4b equals 43 minus 15 on both sides. 4b equals 28. Divide both sides by 4. So b is equal to 7. Okay, so now I just need to write my partial fraction decomposition. So a is equal to 5. So I just have 5 over 4x plus 1 plus b, which is 7, over 3x plus 7. let's see if I can get an eraser here. Eraser, let me rewrite that a little neater. For x plus 1. That's a little better. All right, so hopefully you're finding this helpful. I'll get through it as quickly as possible, but I guess if you don't want to watch all of it, you can go ahead and fast forward it. All right, let's try another one. There's 6 of them that I have on here, and then there's a couple extras, but I'll just have you set up the form for those. Okay, this one is similar to the one that I just did. So the partial fraction decomposition of 40x plus 65 over 8x squared plus 30x plus 25. So we have to factor the denominator first. So we'll have 40x plus 65. Factors of 8, so 4x times 2x. And I believe the factors of 25, 5 and 5. Check your inner and outer to make sure they add up. 10x and 20x equal 30x, okay? And 4x plus 5 is a linear factor, 2x plus 5 is a linear factor, so once again, it will write at, so we will have a over 4x plus 5 plus b over 2x plus 5. And then we'll multiply everything by the least common denominator. So multiplying everything by 4x plus 5 times 2x plus 5. So this cancels and you're left with 40x plus 65 equals 4x plus 5 cancels and you have a times 2x plus 5 plus b times 4x plus 5. And this one is similar to the one that we just did. So let's we'll have 40x plus 65. Distributing, I'm going to get 2ax plus 5a plus 4bx plus 5b. Let's group our x terms and our constants. So I will get 40x plus 65 equals 2ax plus 4bx. Put your constants together, the 5a and the 5b. (40x plus 65 equals, take the x out, 2a plus 4b, factor out the x. And then you have your constants. And then you're going to say 2a plus 4b, which is your x term, is equal to your 40. And 5a plus 5b equals your 65. Go back to black. And I am going to use elimination, so I guess the best way to do this is I'm going to multiply this by a -5, and I'm going to multiply this by a 2. So -5 times 2a is -10a. Minus 20b equals -200. And on the bottom I get 10a plus 10b equals 130. Those cancel. I get -10b equals -70. Dividing both sides by -10, b is equal to 7. Okay, so now I just need to figure out what a is equal to. So I know that 2a plus 4b equals 40. So 2a plus 4 times 7 equals 40. 2a plus 28 equals 40. Minus 28 on both sides. 2a equals 12. Divide both sides by 2, so a is equal to 6. So now you can write your partial fraction decomposition. A is 6, so we get 6 over 4x plus 5 plus 7 over 2x plus 5. And I didn't need the extra. Okay, so sometimes you're going to have repeated linear factors. I don't think you're going to find any examples of this in the homework, so I'm just going to have you kind of set up an example of what this form would look like in case you come across it in the future. So I just say write the form of the partial fraction decomposition of this function. Notice you have a repeated x minus 3 because you have an x minus 3 squared, and then you have the linear factor x plus 1. So if you were going to write the form of this partial fraction decomposition, this is how it would look like. You would have to have a over x minus 3 plus b over x minus 3 squared, and then you'd have a c over the x plus 1. Okay, that's what it would look like. All right, let's see what this one would look like. Write the form of the partial fraction decomposition of this function. So here, notice you have x minus 1 cubed. Okay, so that's a repeated linear factor. Just went back to that previous one. So if I was going to write this, you would have a over x plus b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed. It's giving you an idea of what those look like. But I don't think you're going to have to do any of those in your homework. However, on this case 3, the irreducible quadratic factors, you will have some of these. So let's go ahead and step through some of these. Notice the numerator takes a different form when you have a quadratic factor on the bottom. It's going to take the form ax plus b. It's not just a constant. So let's try a couple of these. Now this is nice because they already factored it for us. So the x cubed plus 2x squared plus 9x plus 18 factor to x plus 2 times x squared plus 9. So if we were to factor that, we would have had to factor that by grouping, but they already did it for us, okay? So x plus 2 is a linear factor, but x squared plus 9 is quadratic. So when we rewrite this, and I'm going to probably need 2 slides to do this one, the f of x is going to be just a constant a over x plus 2. Plus, but since x squared plus 9 is quadratic, the numerator is going to take the form bx plus c. And notice I have to use different variables for that. I can't use the a again. Bx plus c over x squared plus 9. All right. Now, I wish I would have done something else. I'm going to erase that. because I want to set that up differently. Bear with me. So let me just go back to this. So I'm going to have 2x squared plus x minus 19 over x plus 2 times x squared plus 9 equals a over x plus 2 plus bx plus c over x squared plus 9. And so now, just in like the previous examples that I did, I'm going to multiply everything by the least common denominator, which will be, as you might guess, x plus 2 times x squared plus 9. And as before, this cancels with this cancels this cancels this. So I'm left with 2x squared plus x minus 19 equals a times x squared plus 9 plus bx plus c times x plus 2. And so now I'm going to have to distribute all of this out. So I'm going to get 2x squared plus x minus 19 equals ax squared plus 9a. And now you need to FOIL this, okay? So you're going to get plus bx squared. Bx times x is bx squared. You do your outer, bx times 2 is 2bx. Your inner c times x is plus cx. And then your last c times 2 is plus 2c. So you have 2x squared plus x minus 19. And now you want to group your like variables. So I'm going to have your ax squared and your bx squared together. And then you want your 2bx with your cx and your 9a with your 2c. So I have 2x squared plus x minus 19. And now you're going to factor out your x squared. So you're going to have a plus b times x squared plus 2b plus c times x plus your constant 9a plus 2c. So that's going to give you 3 equations, a system of equations. So you have a 2x squared over here, and you have a plus b times x squared here, which means a plus b equals 2. You have a 1x here, and you have a 2b plus c here, which means 2b plus c equals 1. And then you have a negative 19 equal to your constant 9a plus 2c. So 9a plus 2c equals negative 19. Okay, so I'm going to take those 3 equations that I just wrote down and move them to the next slide to work with those. Okay, so I have a plus b equals 2. I have 2b plus c equals 1. And I have 9a plus 2c equals negative 19. Now, what I'm going to do on the first one is I'm going to go ahead and just take a plus b equals 2 and solve for a. So if I minus b on both sides, that means that a is equal to 2 minus b. And I'm going to plug that into this one right here. I'm going to plug this into this equation right here. So I'm going to say 9 times a, and instead of writing a, I'm going to put 2 minus b plus 2c equals negative 19. So that's going to be 18 minus 9b plus 2c equals negative 19. And then I'll just move my 18 over. So I have negative 9b plus 2c equals negative 37. Let's see what the screen looks like. So now I'll have 2b plus c equals 1. I really wanted a different color. 2b plus c equals 1. And I'm going to write negative 9b plus 2c equals negative 37. And I'm going to multiply this by a negative 2. So I'm going to get negative 4b minus 2c equals negative 2. So negative 9b plus 2c equals negative 37. So negative 13b equals negative 39. Divide both sides by negative 13. And b equals 3. So you have your first constant there. My hand is falling asleep. So now that I know what b is, I know that a plus b equals 2. So a plus 3 equals 2. So a equals negative 1. And then 2b plus c equals 1. So 2 times 3 plus c equals 1. 6 plus c equals 1 minus 6. So c equals negative 5. So I have everything I need now to write my partial fraction decomposition. Okay. So a negative 1. Let me go back to a different color. A, which is negative 1 over x plus 2 plus b x plus c, or minus 5, over x squared plus 9. Which means your f of x was equal to negative 1, and your g of x was equal to 3x minus 5. You see how that works? This is a lot of work, especially when you go back to do the substitution. Okay, and the next couple that I have are very similar to this one, so I'll just move on to those. There's 2 more to do. Okay, so once again, this has been factored for you. Okay, but once again, they're wanting to know what your f of x is, which is going to take the form as of a, and your g of x, which is going to take the form of bx plus c. Okay? And that's nice that they've already factored this for us. Okay. So we have negative 13. See if I can write a little bit smaller. Negative 13x squared. Get my eraser for a second and start. Negative 13x squared minus 35x minus 37 over x plus 4 times x squared plus x plus 3 is going to equal a over the linear factor x plus 4 plus bx plus c over the quadratic factor x squared plus x plus 3. Let's multiply everything by the least common denominator, x plus 4, multiplied by x squared plus x plus 3. This cancels with all of that. You're left with negative 13x squared minus 35x minus 37 equals a times x squared plus x plus 3. That cancels with that, plus bx plus c, which you're going to have to FOIL with x plus 4. So we have negative 13x squared minus 35x minus 37 equals ax squared plus ax plus 3a plus bx squared, FOILing, outer plus 4bx, inner plus cx plus last, which is 4c. So I have negative 13x squared minus 35x minus 37 equals, let's group our x squared terms, which is an ax squared plus bx squared and then group your x terms. So you have an ax plus a 4bx plus a cx, and group your constant terms, which is a 3a plus a 4c. And now let's factor those out so you can see things more easily. Minus 35x minus 37. So we're going to have a plus b times x squared plus a plus 4b plus c times x plus your constant 3a plus 4c. All right, now let's just go ahead and see what our system of equations looks like. I'll write it in green. So a plus b will equal negative 13. A plus 4b plus c will equal negative 35. And 3a plus 4c will equal negative 37. And I'll rewrite those on the next slide. And then we'll figure out what a, b, and c are. Okay? So, and just once again, we're trying to find f of x and g of x. All right, so we had a plus b equals negative 13. We had a plus 4b plus c equals negative 35. And we had 4c plus 3a equals negative 37. All right, looking at this first equation right here, a plus b equals negative 13. Let's solve for b. So that means that b will equal negative 13 minus a. And I'm just going to plug that into this equation right here. And if it helps, I'll get a different color. Ooh, how about purple? So I'm going to have a plus 4 times b. So I'm going to plug in negative 13 minus a plus c equals negative 35. So I'm going to have a minus 52 minus 4a plus c equals negative 35. So negative 3a plus c minus 52 equals negative 35. Add 52 to both sides. So negative 3a plus c equals 17. And now I can put that with this one right here. So I have 4c plus 3a equals negative 37. And I have c minus 3a equals 17. And this is going to work out nicely because I can just add those together. I'm going to have 5c equals negative 20. Divide both sides by 5. And c equals negative 4. I probably should write a little bit smaller so I don't run out of room. I'm writing too big. All right, so c equals negative 4. Let's plug that back in. Let me get a different color. So c equals negative 4. We know that c minus 3a. Nope, it didn't change color on me. C minus 3a equals 17. Negative 4 minus 3a equals 17. Add 4 to both sides. Negative 3a equals 21. Divide both sides by negative 3. So a is equal to negative 7. And we know that a plus b equals negative 13. Negative 7 plus b equals negative 13. Add 7 to both sides. So b is equal to negative 6. All right, so let's go ahead and rewrite this. So we know that a, which is negative 7 over x plus 4, plus b, x plus c over x squared plus x plus 3 is our partial fraction. I'm just checking over that to make sure I did it. Bx plus c. Okay, so that means f of x equals -7 and g of x is equal to -6x minus 4. That's how Lumen would want you to plug those in. All right, we have one more problem to do. If you're still following along with me, it'll be similar to that one. So we'll just go ahead and jump through this one if you're still with me. So we're going to have 12x squared minus 10x minus 12 over x squared plus 2, which is quadratic. X minus 3 is linear. So we're going to have our linear one, we'll call our a over x minus 3. Plus our quadratic will be bx plus c over the x squared plus 2. And we'll multiply everything by our least common denominator. X squared plus 2 times x minus 3. X squared plus 2 times x minus 3. X squared plus 2 times x minus 3. X minus 3 cancels, x squared plus 2 cancels. So I have 12x, I have 12x squared minus 10x minus 12 will equal a multiplied by x squared plus 2 plus bx plus c, which I'll need to multiply by x minus 3. So we'll have to FOIL that. My hand is still asleep. All right. So 12x squared minus 10x minus 12 equals ax squared plus 2a plus foiling. We get bx times x is bx squared outer minus 3bx inner plus cx last minus 3c. Let's go ahead and group our like terms. We'll have 12x squared minus 10x minus 12 equals ax squared plus bx squared. Your x terms, negative 3bx plus cx, and your constant terms plus 2a minus 3c. (12x squared minus 10x minus 12 equals a plus b times x squared. Factor out your x squared. And then we're going to have plus c minus 3b times x plus 2a minus 3c. So your linear equations, a plus b will equal 12. C minus 3b will equal negative 10. And 2a minus 3c will equal negative 12. Okay, and so I'll take those to the next slide. I won't take those to the next slide because I didn't give myself a next slide. Wonderful. All right, well, we'll just have to work with this. Okay. I'm going to go back and rewrite. I'm going to rewrite these up here where they're a little smaller. A plus b equals 12. C minus 3b equals negative 10. And 2a minus 3c equals negative 12. Okay, so if a plus b equals 12, if a plus b equals 12, then that means b is equal to 12 minus a. And I'm just going to plug that into this one right here, okay? So I'm going to have c minus 3 times 12 minus a equals negative 10. So that's going to be c minus 36 plus 3a equals negative 10. And then I'm going to add 36 to both sides. So c plus 3a equals 26. So I have c plus 3a equals 26. And then I have the 2a minus 3a equals negative 12. So that's negative 3c plus 2a equals negative 12. And I am just going to multiply this by 3. So that is going to give me 3c plus 9a, 3c plus 9a equals 78. And negative 3c plus 2a equals negative 12. So 11a equals 66. So a equals 6. Okay, and we know that a plus b equals 12. So that means b also equals 6. And so all we have left to find is c. And we know that c minus 3 times b, which is 6, equals negative 10. So c minus 18 equals negative 10. If we add 18 to both sides, c equals 8. Okay, so now all we have to do is rewrite our partial fraction decomposition. So let me see if I can find some place to squeeze this in here, since I didn't give myself a blank slide. And go back to black. So really for the a here, actually instead of rewriting it, since I have it mostly at the top, whoops. For my a, I just need to have a 6 right here. And my bx plus c, I just need to have 6x plus 8. Okay, so you have 6 over x minus 3 plus 6x plus 8 over x squared plus 2. That's your answer, and I'm sorry that that's such a mess. All right, so I think we've done plenty of examples of that. You will not have any repeated irreducible quadratic factors, but I just wanted to show you what that would look like, how you would set up the form of that. So if you're still listening, once again, and then I'll cut this off, you would set this up as, let me show you how you would set this up. you would have a over x plus b over x squared plus cx plus d over x squared plus 3 plus ex plus f over x squared plus 3 squared. That's the form that that would take.